Hello, everyone. D. Alfred Ostrowski here. In this recording, I'm going to be giving a tutorial / demonstration of fine-tuning for the TinyLlama LLM. I'm going to be following the example presented in the Medium article that you see presented here, as well as some assorted YouTube references and online references. As usual, everything's going to be documented in the associated GitHub, starting with the README install, and is going to be also including the references and the references I used to get these examples to work, because they didn't work out of the box for me. As usual, no fault to the authors. They all did a great job. However, this is a very dynamic environment. Things are changing constantly, so we have to persevere through them. So as usual, I'm going to be starting from square one. In this case, I'm going to be leveraging Google Colab as the platform, as opposed to my usual reliance on Amazon AWS. Colab gives me a more cost-effective access to GPU processors. Now, I've done a prior video, you can take a look at it, where I implement the TinyLlama from Amazon, but I'm not doing the training. So the training, the associated libraries, and the computational resources, the interfacing with the GPU processing necessitates the use of a GPU. And again, as usual, my similar philosophy, this is providing a better means of implementing a solution that is platform independent, that you can run it off of a served architecture. And this just makes it more effective for technology transfer and getting you up and running immediately, training your own localized LLMs using your own private data. And we're starting with some sources, and I may be creating more content, looking at other data sources and looking at the results. But this is an excellent example, in my opinion, working with the colored data set. And this is to be found on Hugging Face. You're going to need a Hugging Face account as well as a Google account if you don't have them already. So I'm going to get started. Again, I'm going to be cut pasting directly from my GitHub, as I usually do. And I'm going to go into Google Colab. It's colab.google.com, which I already have here up on a tab. I'm just going to go jump right into it, start a brand new notebook, and I'm going to show you my configurations and the steps I had to do. Most importantly, the fine adjustments that I had to make to get these libraries up and running, because I did have some problems with the library installs, as they have presented earlier and successfully on a number of internet-based resources this year. So here I am. I'm in colab.google.com. It takes you to Google Colab Research, and I'm going to create a brand new notebook, start from scratch here, okay? And again, I'm going to make this as I usually do. Everything is included in my README install. And I would encourage you to follow directly along with this video if at all possible, because it's going to give you a means of getting this up and running. And again, I had some issues getting these examples to work in the first place, and there is a big difference between the fine tuning and just getting TinyLlama up and running. Okay, and I'm not going to get into the details of these libraries too much, talk a little bit about it. I'm going to perhaps generate more content. We're going to dig in deeper to this, but here, towards my typical philosophy, I'm just going to get you up and running and have a working model, okay? And in the land of the blind, right, the one-eyed man is king, right? So here, to have something running always trumps having nothing running and studying all this stuff to no avail, right? It's no purpose in learning it if you can't get this up and running appropriately. So the first thing I'm going to do is install the Bits and Bytes. This is a rapid CUDA library that allows you for GPU access for your optimizing your computational resources. Okay, and I'm going to do a restart after this per the instructions that people have posted on Stack Overflow. And we're going to let that run, and then we're going to proceed as usual. I got a couple extra fixes I'm going through, and again, everything's well documented. It is also in my README file, as well as in a separate references text file under the associated GitHub. Okay. And there's nothing left to back up, right? There's no project or anything. It's just the notebook as you see here. So looks like it successfully installed. Now I'm going to go into runtime, okay? And this is also very important. I'm going to change the runtime type, and I use the T4 GPU, okay, and set that accordingly. Could have performed that initially, but it doesn't matter in either case because I'm going to do the restart session and run all, and it's going to reinstall that. A little bit cumbersome, but again, I had some discrepancies among that installing the libraries and some conflicts with the Python PyArrow library. So, and you'll see we get a couple errors it trips through in the next installs, but again, everything works as advertised. Okay, looks like it installed, and we can just double check that runtime. Okay, I want to make sure that we get that right here. And I've experimented with the other GPU-based libraries. This is working fine for me. I also want to add, this is a free resource. I pay $10 a month right now to get a little additional computational resources. You might be able to get by with free. You can experiment with that. But what I found with some of these somewhat free services, right, if you at least get the initial plan, you're going to get a little better support in terms of running the applications that you want to, especially as you're scaling up here. So let me proceed here. And I'm just stepping through my prior installs here. So here I have a pip install of the CUDA library. And again, this is in support of some of the conflicts running the pip installs. And this is documented. There's, I believe it was a Google employee that actually posted this, or NVIDIA, I can't remember, but the resources are included. You can dig deep into that. Again, I'm not going to go deep in the weeds on this. Let's get this up and running and see this, because the LLMs, they run as a black box, right? We want to do a lot of experimentation and test and make sure that the model, in this case, I'm going to create two versions of my model. It's a variation of a lot of the exercises here that we can see it running without the fine-tuning and with the fine-tuning, and notice the difference. You might be able to fool yourself because perhaps some of that data is already in the LLM. So there's a lot of information on TinyLlama and the LLMs and Meta, and their models are provided. Again, I may provide more content on that, but here, the main purpose is to get up and running. So we did a successful install. We got a minor dependency error here, but it works in spite of that. So I'm just going to proceed on, and that's the only somewhat of a red flag that we get here. So let me move on here. I got one more install in somewhat of support of a fixing the existing conflicts with the libraries and the pip installs, and a little more details are around that in the references here. So that installed appropriately. Now I can move forward to the validation. We can print out the libraries here, and I'm just doing this for to be a completionist here, and I don't want to generate anything. Sorry about that. This is just going to validate the libraries are installed and give me back the versions. And everything looks appropriately. So now I can do typical install of accelerated PEF, bit-splice transformers, TRL. And again, moving forward to try to break these down a little bit deeper. Let's get this model up and running and go through some of the basic operations and training associated with it. And we got a successful install here. So everything looks appropriate. Now I'm going to install or connect to the Hugging Face and log into that and do the appropriate login. So you can set a environment variable here to the left, HF secret. I can take my token from Hugging Face and insert it in that and use it across my notebooks. I'm kind of going from scratch, and I'm just going to put this in here. It prompts me for a token, and it actually is nice enough to take me to the tokens page. You can have to fish around a little bit if you want to do it independently. And I just clicked in to get to that. I have the access token. You can see I've generated a lot of tokens. I'm going to create a brand new token, just again to show you the process. You see, I've already done this before. I'm going to call it Alfred 10, okay? And I'm going to just set basic user permissions, okay? And I may not even need all these, but I definitely need to go, don't have to go beyond that, okay? And I'm going to scroll it down and create my token. Okay, so you can see I'm exposing my token here. Before I publish this video, that token is going to be deleted. So please don't try to use my token. Okay, it's not going to be there anyway. And it's free. Okay, there's nothing to steal. So try to refrain from any dubious activity. So I did a copy of that, and I'm just going to paste that in here. And the login successful. So I'm logged in. That's going to allow me to have free access to huggingface.co. And that's going to allow me for a couple of things, right? I can pull down my llama model, the TinyLlama, and also the data set is available there, and I can use it as storage as well. So now I'm going to pull in a number of the major libraries that I'm going to use for this demonstration, including Torch, Python datasets, the sub-libraries under the transformers, TRL, and just load that in. That's going to run very quickly. Next, I'm going to define 3 data sets here, variables through the variables. Whoops, didn't copy. Now, I want a brand new output model, so I'm going to call this Alfred 10, okay, to be consistent with my token. And I'm pulling down the Berkeley colors and the TinyLlama chat model. And with the colors, you can look at the Medium article. It's associating hex codes directly to the colors. And is it already in the model? It could be okay if they're scraping the web. However, it isn't, because I'm going to run the model twice, one which is not fine-tuned and one that is, okay, and we can examine the comparison. So I have the model ID of TinyLlama and the associated output model. So we just load that in memory. Now I'm going to define a model called formatted train. And you can break down the Python if you want and take a little bit deeper dive into that. Basically, it's going to put it in the associated format of input response. And you're going to be able to see as we read in the data set and prepare the training data, you can read it out line by line if you like, and examine the exact format. It's basically it is putting it into a JSON-based description. It's going to be used to train the data. And once you see it and get a good feel for how these Python libraries are operating, then you can understand how to formulate your own data sets to accomplish this. So here I'm going to pull in the data set and we're going to take a look at it, okay? And this is going to run relatively quickly. It's pulling it down from the Hugging Face. And it worked appropriately. So I can print out data. I got features, color, description, and text. It's important to note I'm using 33,000 examples. So you're going to try fine tuning and you have a relatively small data set, you may not get the appropriate results that you may be expecting. Let's say if you've done other machine learning models. Okay, so keep that in mind as you move forward. If you're not getting the right result, which I've seen a lot of variance, then it's in your best interest to bump it up to at least into the thousands, okay, if not more. So here I got a color, all zeros, that's pure black. So I have a text description associated with a color. And let's just do one more just to get a flavor of what's going on here. Let's just take another data set, let's say data 100, and see what that produces here. Is a dark blue, and that's a 002040. So it's hard to interpret as we get into the whole variation of colors, okay, to look at a hex code and say, oh, that looks appropriate. So we have a function here that's going to print out the color towards the hex code, and you'll be able to input a text description and get out the hex code and test that hex code by printing out the color and saying, okay, it actually read it and it learned an appropriate hex code, okay, that's commensurate with the text-based description here. So here I'm going to grab the model and the tokenizer. This is reading the model ID. Okay, so it's going to take my pre-trained TinyLlama, and again, I'm including references on that, and I can talk more in further content as to all of the background information around TinyLlama. There's a lot of things to break down, but here, let's just get it up and running. Okay, so here I'm going to do get model and tokenizer and pull that in appropriately. Now this is a just over 1 billion parameter model, and this is an interesting comparison to some of the higher end models that Meta is providing that can go 50 billion or more, and it accomplishes a couple things. Okay, it gives you a more resource, smaller resource model. Okay, it's going to take obviously a lot less resources to work with and fine tune. It's also going to give you means of comparison between exactly what are these high end LLMs getting for you. Okay, so this pulled it in appropriately. And now I'm going to set some parameters. This is going to be read into the training portion. This is some configuration parameters for LoRa. LoRa is a library that is going to allow me to integrate the pre-trained component with my existing model. And I'm going to use 250 steps in the fine-tuning and 3 epochs, and leverage all the default parameters that most of the other tutorials have been using, okay, and documentation. I'm going to pull in the trainer now. Now I'm going to do the training of the data set that's being provided with the Colorist model parameters. And this completed successfully. So now I'm going to start the training. I'm going to pause out once this gets started. Whoops. Because it's going to take about 5+ minutes, 5 to 8 minutes or so. And I'm just not going to sit here and wait for the dead space. So I'm going to initialize this, and we're going to launch this and not do anything else except wait for it to complete. If you are doing some dry runs, you could try it with less parameters. However, it's going to affect the accuracy and performance of the model. So started here, we're going through 4 already. We got all the way to 250. So I'm going to let that run. I'm going to pause out just for a quick 5 minutes or so. Okay, and I'm back, and this is almost completing here. We're at 230 steps. While we're watching that complete, I'm just going to quickly pull in the Berkel Libby page. And again, this is the dataset Berkel Libby colors, and you can scroll through here and see a number of the examples and see how they're described. Okay, and obviously there's a lot of examples to look upon, and you don't want to, if you want to exactly duplicate what I'm doing here, it's going to be your best interest to use this particular data set. And there are a lot of colorist type models or pre-trained models. So at least give you a 1-by-1 means comparison. So the training is complete. Okay, so we can complete on here. I can print out the attributes of the model that's generated here at this point, and we can take note of that. and we can move forward. So now I'm going to take the model, and again, I'm going to take the existing TinyLlama, and I'm going to take the pre-trained model, which we just did right here with the colors data set, and we're going to leverage the LoRa library is going to allow us to merge them. Okay, so this is in comparison to having to retrain a complete neural net. Okay, so that allows for a merge of the fine-tuning model. I'm also going to obtain access to the model without fine-tuning it. We have a means comparison there. So here, again, if you're running my examples, you're going to want to pay attention to your input data set. And I'm using the checkpoint 250. You may not have the highest accuracy. Accuracy varies a little bit, but on average, obviously, at the end, it's going to be lower or near the absolute lowest. Okay, so here I'm going to read in from Alfred 10, checkpoint 250, and I'm reading in the model ID. Again, that is the TinyLlama, and the PEF model, that is the I want to use the pre-train, and then I'm going to merge the two. Okay, so that's accomplished through this set of code. And I'm going to read a couple extra libraries. One to do the formatted prompt for testing the new model here. Whoops. Keep on pulling in the old one. So paste that in. It's the formatted prompt, and you can split hairs on the Python code moving forward here. I'm going to pull in a library, and that is going to allow me to print out the color space, and it'll just give me formatted print directly to the screen of the colors. Okay. And as mentioned, I'm going to duplicate a portion of this code, and I'm going to assign it to model 2. Model 2 down here. This is my model before merging it. So I'm going to pull that from the pre-trained and assign it to another variable. That all means a comparison. Okay, I actually know and be able to confirm that I have the appropriate training. Okay, so here I'm going to pull in a generate response module. I'm going to have two of them. One is going to access the fine-tuned model, and one is going to access the actual base model. And I'm not going to step through all the code here, just going to run, but at least you can have an idea at the high level exactly how this is being applied. And I'm going to create the generate response 2. And again, this is going to give me the means comparison. And I'm accessing the difference here as I'm accessing model 2. And this is taking the, in both cases, right? We're reading the formatted prompt, we're accessing the associated model, and we're going to be generating the output parameters based on that. So now I can run this. Okay, let me just run TinyLlama as it is. I'm going to use the generate response 2. Okay, I'm going to ask for a light orange color, and let's see what the result is giving us. So it gives it a valid color recording and really doesn't give me any information, doesn't give me the hex code. Okay, why? Because quite simply, I don't have the fine tuning, but I want to understand the difference between the two. Okay, so here I do the generate response. This is the fine tuned model. And here I have a hex code that's being generated. Okay, and I can cut paste that. And we can put that into my generator. I'm just going to open up a notepad here and just stow that off to the side. Okay, so I can have that. And it's a little bit lower font than my liking to be able to read it. So at this point, I can do a print color space. And I want to put it in the appropriate quotes here. And I believe I missed a line from the actual, there we go. I had to do a print color. Let me redefine print color space. I miscopied that. So just go back here. And I can do this again and get the actual result. Nope. Do it down here, just so we're consistent. There we go. Because it's hard to read those hex codes unless it's all zeros, you know that's black. But if I'm looking at something, let's say with this example with the light orange, we can look at that now and have the confidence in knowing, okay, so what did I do? I have a model that wasn't fine-tuned and it didn't generate anything of relevance. And then I trained it on 33,000 hex codes to color text-based descriptions. Okay, and they looked at the Colorist set. And then I took the hex code to actually have the comfort level that it was being generated, that it trained it. Okay, this isn't savant learning, right? And it's non-deterministic. So it may give you variations on the output. But if you look at the colors, if the colors are matching, then you have that confidence level and you can move forward with your own data set. Okay, let's do another test here. And I'm going to try light blue, okay, just to try a different description. And again, I can use my base model that doesn't have any fine tuning. Okay, you want that confidence. You want the confidence of knowing that your training is actually affecting something. You have something that's already been trained in those Billion parameters. Okay, then you may fool yourself. Okay, that you're actually getting the appropriate results. And I think that in some cases that can be misleading because it's running as a black box. Okay, it's hard to look at this data and have the complete comfort level and means of validation. So here I'm going to do the generate response. This is the train, and this comes back with hex code. Okay, so now I can run print color space and print that in there. And let's see how that looks. So very dark blue. And we have that, right? We got a dark blue showed up and it looks good. Okay. So there you have it. We downloaded TinyLlama to Google Colab. We loaded the associated libraries, did the necessary adjustments to get them up and running. We also downloaded from Hugging Face the Colorist data set. And we fine-tune our TinyLlama. And we notice the difference between the base TinyLlama and your fine-tuned model. Okay, that has learned the hex code translations of these text-based descriptions. As usual, everything is going to be on the associated GitHub, along with the associated references. Thanks for listening. See you on the next video. If this helps, please consider like and subscribe. Thank you. Talk to you soon. All right, bye now.